is Ramesh, Assistant Professor in Excel Engineering College. So I am going to present 4G technology. That's it. So this is the content I am going to present. So what is first is the introduction, and then what is 4G, fourth generation technology. And then that is evaluation of 4G starting from first generation 2 and 4G, and then look up fundamental, what is the basic requirements if you are going to use the 4G technology, and then the basics of 3G, and then we are going to deeply discuss the 4G technology. So what is 4G? So G means nothing but this generation, starting from first generation, second generation, third generation, and then this is the fourth generation. So basically LTE is the technology we are going to use in 4G. Okay, what are the methods we are going to use? In case of 3G, we are going to use the UMTS technology, and the same thing in fourth generation, going to using technology called LTE, long-term evolution. That is the long-term evolution is started in 2004, and then the partnership with the 3GPP. Okay, the 3GPP technology used in 3Gs also. It's the advance of 3G. This 4G. So that is the TE. It is in important because it will bring up to 50 times faster than other for improvement and much better spectral efficiency to cellular network, means other cellular network compared to other 2G and 3G cellular networks. This performance is 50%, 50 times better performance. That is LTE introduced the high data rate of 300 Mbps. That is downlink data rate, this peak data rate, and 750 Mbps for uplink data rate. Up to that is in a frequency carrier of 20 MHz. There is a different kind of carrier frequency using in LTE network. This 5 GHz, and then the 5 MHz, and then 1.4 MHz, and then 50 MHz. There is a 20 MHz carrier frequency. Using that, you can 300 Mbps peak rate. The LTE is ideal technology support for high data rate. So here using the technology called voice over IP. That is packet switching, the streaming, multimedia, video conferencing, and even high-speed cellular networks. So remaining the technologies are not supporting voice over IP. It is 4G technology is fully based on IP base. Okay. So these are the previous technologies. 1G can only support for speech process. There is no data communication. In that second generation, you can for speech and data communication. That is the data rate. It is in kilobits. That is the different kind of techniques you are using, either CDMA or TDMA or FDMA. So these are for the voice communication. The data communication go for GPRS, and then Edge. Edge is the 2.5G technology. So in third generation, this is for high quality multimedia services. We are going to increase the data rate. We go for 3G technology. That is 3G technology is CDMA 2000, and that is for only for CDMA applications. And then WCDMA for GSM applications, wideband code division multiplexes. So it is 4G high download rate, same, then 40 Mbps and then 5.0 Mbps for a high download and upload speed in 3G technology. But if you go for compare with the 4G technology, it is dramatically very high. In case of 3G 40 Mbps, in case of 4G it is 300 Mbps. So in the same way, the 4G, that is packet switching network in 4G technology you are following. Up to 3G technology, we are following for circuit switching. There is a least line between source to destination or sender to receiver. But in case of 4G, all the voice and data communications only for packet switching. The data will fall only in the format of packets. Each user allocates separate IP address. So this is the LTE key parameters. Here in LTE, we are going to using the concept called OFDM, orthogonal frequency division multiplexes in LTE. So the basic parameters, that is channel bandwidth. Here using it is 1.4 MHz, 3 MHz, 5 MHz, 10, 15, 20 MHz bandwidths. Different kind of bandwidths are available. In case of 3G, you have only 5 MHz bandwidth. In case of 2G, you have 25 MHz bandwidth. In case of 4G, there were different kinds of bandwidths we are going to use depending upon our requirements, usage requirements. So we have the total bandwidth can be split into resource blocks. Depending on the bandwidth range, the number of resource blocks will vary. Okay, and then modulation technique, here using QPSK, QAM, and then 64 up to 64 QoM modulation technique. For downlink and uplink the same. Optional for handset. Now depending upon the handset requirements and specifications, the modulation technique will vary for the upload. So and then downlink we are using orthogonal frequency division multiple access, that is orthogonality between, there is a phase shift between one user and another user. So there is a more number of carriers in the OFDM. And so uplink we have single carrier. In downlink the base station can transmit more number of carriers, but mobile terminal can't able to transmit more carriers. Single. That's why it is single carrier. The user can transmit only the. That's why upload speed is low compared to download speed, data rate. Okay. So the MIMO technology, multiple input, multiple output. Either 2x2 antenna or 4x4 antenna are going to use. 2x2 means 2 transmit and 2 receive antennas. Next. So this is the frequency bands, LTE frequency bands you are going to. That is 40 frequency, 32. The duplex mode is FDD, frequency division duplex. So another remaining frequency bands you are using duplex mode as TDA, time division duplex. In case of 4G we are only going to use frequency band 1, and then frequency band 3, and then frequency band 5, and then up to frequency band 14, and then 33, and then 40. These frequency band only nowadays we are using, but maximum can fully implement 4G technology, you can use all the frequency bands. Okay. Next. So this is the key 3G comparison of the 3G and 4G technology. So that is network architecture, wide area cell network, that is 4G technology, hybrid, that is integration of Wi-Fi, Bluetooth, and then wide area network. And then that is frequency band, that is 2100 MHz can use for 3G, and then 4G 1800 and 2300 MHz. Okay, these megahertz frequencies used for India. Okay, but frequency range from 2 to 8 GHz. Okay, but India we are using 1.8, and then it's bandwidth maximum of 100 plus MHz, and the data rate in 4G 20 to 100 MHz. These are the OFDM technologies. Switching. So 3G technology, circuit and packet switching. 4G were only for packet switching. In case of IP address, the 4G technology is only for IP based. So 3G technologies, that is multiple versions. So only 4G compared to only for IP based. Next. So this is the major LTE technologies. Orthogonal frequency division for a download, for uplink, suppress carrier. That is SC, FDM. And then MIMO technology. Why you go for MIMO technology means you can increase the data rate. If you want to maintain the 300 Mbps data rate, you have to use 4x4 MIMO antenna, 4 transmit antenna, and the receive side also you have 4 receive antenna in your smartphone. Next. So these are the OFDM technologies. In case of LTE, we can combine frequency and then time domain. That's why fast Fourier transform, IFFT, inverse Fourier transform, can be used to convert your frequency domain to time domain. This is a very important one. In 4G technology, you can combine of time division and then frequency division concepts. So this is the OFDM. Normally WCDMA have only 5 MHz. In case of OFDM, that 5 MHz can be split into subcarriers. So this is the subcarriers. So that is single frequency can be split into subcarriers, 52 subcarriers. Each subcarrier can having 3112 kHz frequency band. So this is the downlink OFDMA. It is only for considered on downlink. So that each carrier, each subcarrier, 5 MHz can be split into subcarriers, 312 kHz subcarriers. That subcarriers can be, that is frequency domain can be converted into time domain concepts. Next. So these are the time domain, OFDMA, time frequency multiplexing. That is can be split into already, when the bandwidth can be split into resource blocks. Okay, 6 resource blocks, 8 resource blocks. So that one resource block equal to 180 kilohertz. In case of already I told that is 52 carriers, number of carriers, total frequency total subcarriers. So one resource block equal to 12 subcarriers. One subcarrier frequency equal to 50 kilohertz. So here deeply, that is one resource block, that is the diagram, user 1, user 2, user 3, user 4. So that one user may be using more than one resource blocks also, it is possible. And then that is one super frame equal to 1 millisecond. Means 1 millisecond means you have 2 slots. At the time one user may be use more than one resource block also. So at 1 millisecond the resource blocks allocation to the base station to the user it will vary. So these are the overview of 4G technology. Next. So this is the frequency band used in Indian telecom operations. 850 MHz, 1800 MHz, band 3, and then 2300 MHz, and then 2500 MHz. Next. So this is the Reliance Geo frequency band in India. Normally band 3 it is in LTE and then frequency division duplex concepts. Frequency band that is 1700 MHz and then 1800 MHz also uplink and downlink. That is bandwidth 5 MHz. That 5 MHz can be split into resource blocks. The resource blocks can be split into number of subcarriers. That number of subcarriers can be modulated and then transmitted using time division duplex concepts. So band 5, the same 5 MHz, it is 850 MHz frequency band. And then band 40, you have 2300 MHz. But in this situation, the bandwidth is 20 MHz. Suppose when you increase the bandwidth, you have more number of subcarriers. Yes. So in 4G in India, so has already begun the process of 4G. It is among the late comers in 3G. This 4G technology so has taken 3 years for the government to decide on 3G spectrum auction policy. So that is 4G would face the same delay unless India wants to catch up with the rest of the world. In case of 4G technology, it is lagging. So these are the advantages. So high usability, support for multimedia applications. So high data rate, the downlink data rate, there is a streaming of media applications, and higher bandwidth, tight network security. Security is also available. And then disadvantages means the equipment required to implement next generation network, it is expensive. It is very expensive. Carriers and providers have to plan carefully to make sure that expenses are kept realistic. Means the implementation cost, the base station implementation cost, everything it is very high.